Review for Lesson 3. When I looked over this lesson and before I began to write it, it brought back memories over the past years. I thought about when I was going through classes and the instructor strongly emphasized one thing when he talked about conductors. The biggest and most dangerous conductor there is out there is you. A conductor is anything that allows current to flow through it. The body is made up of water and a lot of soft tissue with little resistance, so it makes a great conductor for electrons to flow. Conductors come in all shapes, sizes, and materials. Some of the most well-known conductors we use are aluminum, lightweight brass, switch parts, and copper. Copper, figure 3-2, is a great conductor and the most widely used conductor in electronics. Remember, electrical conduction is merely the transferring of electrons from atom to atom. Conductors allow you to force electrons in one end and out the other at the speed of light, 186,000 miles per second. The unit of measurement for conductors is the Siemens, and the formula used to find conductance is G equals 1 divided R. Conductor size is determined by the cross-sectional area. The cross-sectional area will tell you how much current the conductor will allow to pass through safely. In this field, when referring to conductors, we are speaking about a wire and its size. We use a wire gauge to actually read the size of a wire, figure 3-3. A system called the American Wire Gauge System, figure 3-4, was created to make it easier to determine the size of electrical wire and its current carrying capacity. The larger gauge number equals the smaller current carrying capacity. The cross-sectional area. The wire gauge system has changed and the demands from the electronics field has grown. The first system made a change from 1 being the largest size of wire to that what we call oct, which is 0 and 00 and 000 and quadruple 0, or 1-4 oct, or 1-4 oct, 1 through 4 oct. As demand increased, the circular mills area was added as well. The circular mill system is based on the diameter of the conductor being measured in mils, 1/1000th of an inch. Any wire larger than 4 oct are 250 kcm or kilo circular mill. Remember, 1 kilo is 1,000 to 2,000 kcms or 2,000 kilo circular mills. If you have a 35 kcm to 300, it is equal to 35,000 circular mills. The number of circular mills or C mills in a conductor is equal to the diameter of a round conductor squared. Simply put, a wire with a diameter of 6 mils has an area of 36 C mills. The wire that was just covered has an ability to pass current through it that makes it unsafe for people to touch. For this reason, it must be covered up in an insulated film with some type of material. This material, which is not conductive or does not allow electrical current to pass through it, is called an insulator. Some of the different types of insulators are rubber, plastic, wood, and synthetic material. Rubber tape, such as the figure shown in 3.5, will be used as your personal insulator when performing field work. As time goes on, you will know what different colors represent, but black is for general use. The type of insulation will be determined by the electrical application. For example, if you are installing Christmas lights in your yard and need an extension cord, the wires inside the cord should be insulated with some type of weather-resistant insulator. Some insulators we use are marked with special coating to indicate their use. R is rubber, H is heat, M is oil resistant, and C is corrosion, which are the ones you would see on a regular basis. Although conductors come in many shapes and sizes, you will encounter two types of conductors: wires stranded, figure 3.6, many wires twisted together to make up the conductor, and solid, figure 3.7, which is one wire. Resistance is low in conductors, but must be considered when running long-distance wire pulls. There are 4 factors that will affect the resistance. 1. Cross-sectional area of the conductor. The larger the diameter, the lower the resistance. 2. Type of material resistance. Values vary with type of material. 3. The length of the conductor. The longer conductor, the greater the resistance.
And 4.
Temperature of material. Resistance is proportional with ambient temperature. See figure 3-8. Ambient temperature is the temperature of the material surrounding the conductor, such as water, air, or soil. In cases where the temperature is so low it causes the conductor resistance to approach zero, the conductor turns into a superconductor. Figure 3.9 shows a process for creating a superconductor by reducing the temperature of the conductor. They can be found in medical imaging equipment, but operate on the principle of a motor. Because all of the variations in our field and the need for continued safety awareness, there are organizations that exist to ensure safety guidelines are followed. The National Fire Protection Agency provides us with information on fire prevention. Electricity causes C-class fires and can be put out by disabling power and by treating the fire as a Class A fire, any fire that leaves an ash. The National Electric Code, or NEC, set the standard on how electrical and electronic equipment should be installed to ensure safety for both people and property. The NEC is a 700-page document that will become one of your best friends. The Underwriters Laboratories, Inc., a nonprofit organization that conducts tests on products to ensure public safety, they created a seal to attach to a product that tells the customer it meets safety design standards. The Occupational Safety and Health Administration, or OSHA, part of the Department of Labor, considered the big cheese in the industry responsible for your safety on the job. They have the power to shut down work sites and enforce fines. Although not all facilities are governed by OSHA or municipalities, they still follow their standards. The National Electrical Code set a maximum voltage drop across each branch. A branch circuit, figure 3.10, is wiring from the panel to the last device on that circuit. A maximum of 3% voltage drop is allowed, and a formula can be found on page 59 of your text. This formula can be very helpful when trying to figure out a conductor size that will not cause a high voltage drop. There are 3 conductor pathways to provide a good conductive path for current flow. The breadboard, experimental board, consists of lots of holes lined to an insulated material. You will insert resistors, switches, and various electronic devices via jumper wire to create circuits. See figure 3-11. The printed circuit board is the most commonly used and is made up of conductor material with thin strips of circuit paths for component connections. It uses a heat strip for common connection points and reduction of heat. Solder is used to make all connections permanent at the connection pads. Figure 3.12, bottom view. Although you will learn how to troubleshoot these boards down to faulty components, once in the field you will look at cost first. Most times you will just replace the whole board. See figure 3.13, top view. The chassis is the metallic surface where the components are mounted. It serves as part of the circuit. Chassis pathways are not in great use, but in your text on page 61 you will find a brief description of the metal chassis pathway. Please spend just a brief moment reviewing it because you are unlikely to encounter it again. In building and troubleshooting circuits, there are some devices that are used in most electronic circuitry. Switches, figure 3.13, are used in circuits to stop and start the current flow in a circuit by the use of a mechanical actuator. This actuator comes in a variety of forms, including slide, toggle, and push button. The name will indicate the type of actuator. The letters SPST stand for single pole, single throw, which means that the switch only has one path for current flow and will only operate one circuit. A SPDT, single pole, double throw, has one common connection point and can control current to 2 different circuits, but only one at a time. If you see DPDT, it means 2 circuit paths for current flow with 2 common connection points. It's like having 2 SPTP placed in parallel. Switches are rated by the amount of current they can withstand. If a switch is only rated for 3 amps, exceeding it will prevent it from opening. And the same applies for voltage. You cannot exceed the rated voltage of a switch. Connectors come in many types and are used to connect wires, electrical conductors together. There are many types of connectors available for a variety of usage. The types that will be used by you more often than any other are the wire nut, figure 3.14, and crimp type, figure 3.15. Wire nuts are easily used by putting the wires together and twisting the wire nut over them. The crimp type requires a tool. For this type, you put the wire in the connector hole and crimp with the tool. Once the circuit is built, we must protect the equipment and or components because of shorts, grounds, and opens. The protection devices you will need to familiarize yourself are the fuses and circuit breakers. There are others out there, but these two are in every electrical circuit around. Fuses 3.16 provide short circuit protection and are rated by voltage and current capacity. If a fuse is rated for 6 amps and it exceeds 6 amps, the fuse will open or blow to prevent damage to other electronic or electrical components. Circuit breakers, figure 3.17, are used to protect a circuit from overloads and shorts and are resettable components. The circuit breaker doesn't have to be replaced when it trips. It is telling you that there is a problem. The circuit breaker can be reset. Like fuses, circuit breakers are rated by voltage and by current and operate similarly. There are two ways the circuit breaker can trip, and they are designed by the way they trip. One uses bimetallic strips and the other uses magnetism through coil current or magnetic. The magnetic breaker is more accurate and costs more, but it is more widely used in the industry. In some homes built prior to the mid-1980s, fuses were used to protect the circuit, but all homes built today use circuit breakers. That protection includes a lighting circuit, which brings me to the next topic, lighting. Lighting can be produced in many different ways, but for the purposes of this course, we will focus on the lighting that is produced via electricity. This is accomplished by sending current flow through a filament or energizing through a gas. There are two types of lights, incandescent and fluorescent. Incandescent was discovered by Thomas Edison in the late 1800s. It uses current flow through the filament to produce light. It is the type of light with the threaded metal base that is screwed into a socket. Fluorescent lights use energized gases such as mercury vapor to produce light and will produce 20 times more light than incandescent lights. Fluorescent lights use a ballast to control the current, produce a higher voltage for the filament, and are pin-based or screw-based. When we buy lamps or lights, we generally select them according to the voltage requirements and the watts, which determine the brightness. The amount of light produced is based on candela, which is the amount of light generated by one candle. A lumen is the amount of light generated by a system of lights, and lumens per watt is the amount of light produced for each watt of energy. The last circuit device we're going to cover in this lesson is the resistor. It is one of the most common components used in electronics and is used to create variable voltage drops and limit current. Resistors come in all shapes and sizes and are rated according to their ohmic value. The wattage rating on a resistor tells you how much heat the resistor can withstand before it opens. There are many types of resistors, but I'm going to cover just a few that you will see daily. The first is a film resistor. It is a small resistor and will be found on electronic circuit cards. The resistor is the adjustable resistor. It has the two normal ends you use to connect to a circuit, but it also has an adjustable sliding tab. The tab can be moved up and down, which will cause the resistance to vary. The most common type of adjustable resistor is a potentiometer, which has a rotary knob to adjust the resistance. This resistor can be found in house lighting to control the lights. In that case, we call it a dimmer switch. The last resistor is a thermistor, and it is used to dissipate large amounts of heat in electronic equipment or circuits, which will cause high current. Resistor color coding is used to determine the ohmic value of the resistor. Each band has its distinct representation. They usually have 3 to 5 bands at most. The first band is the first digit, second band is the second digit, third band is the multiplier, fourth band is the tolerance, and if there's a fifth band is the failure rate. The best way to remember how the colors fall into place is to come up with some type of acronym, words used to represent each letter. Review questions for Chapter 3 of Electricity and Electronics, 10th edition by Gerrish and et al. All section review and test your knowledge questions are included, of course, by the authors of the textbook. Answers, narration, and explanations by Hector Vladimir. A conductor is half an inch in cross-sectional diameter. That is equal to 2 blank mils. Fill in the blank. 1 mil equals to 1/1000th of an inch. 1/1000th of an inch equals to 0.001 inch. 0.001 inch equals to 1 mil. 0.5 inch or half an inch times 0.001 inch will give you 500 mils, and which is same as half an inch diameter for a conductor is equivalent to 500 mils. 500 mils is approximately 250 casing mils.
and this is as I gathered from Chapter 9, Table 8 of the NEC. The unit of measure for conductance is the Siemens. What is the circular mil area or C-mil area of number 22 copper or AWG22 copper wire? And it's 642.4. And for that, see figure 3-3, the wire chart in your text. The cross-sectional area of a conductor is measured in blank in C-mils. What 4 factors affect conductor resistance, cross-sectional area, distance of run, temperature, and material? If you'd like to answer these questions before the answer is shown, please pause the video. What is the resistance value of 500 feet of number 4 copper conductor? For that, see figure 3-3 again, the wire chart in your text. I may include that in here. The number 4 copper wire is equal to 0.2533 ohms per 1,000 foot of wire, or 1K foot. 0.2533 ohms times 0.5, which is half. 500 is half of 1,000. 0.5 kilofeet, that's the distance, is equal to 0.1266 ohms. That is the complete and total resistance of a 500 feet of number 4 wire. Beginners commonly build temporary circuits using what kind of device? Breadboard. Find the size of copper conductor needed for a 10 amp load located 150 feet from the circuit breaker. For this problem, where we have a voltage drop, we want to find out the size of the copper conductor that we need so we don't have a pronounced voltage drop. Remember, a voltage drop could make appliances malfunction, electronic equipment, so you want to limit that as much as possible. Remember, 3% or less is what we want for voltage drop for most appliances, sometimes even less than that, 3% of the total voltage. CMA is the area in circular mils. A is the material constant, which could be taken from the NEC. I is, of course, amperage. L is the length of wire, and VD is your voltage drop. Your voltage of 277 volts, in this case, will make it 277 volts, and the allowable voltage drop will make it 1.5. Again, typically, we're looking at 3.0%, but we'll make it 1.5 in this case. The lower the better. We have 277 volts, and we want to drop no more than 15%. So we multiply 277 volts times
0.015,
which is 15%. That'll give us 4.155 volts as the allowable voltage drop. A little over 4 volts it's allowable to lose from your 277 volts. And the formula is written as such: CMA equals K for your constant times I, your current, times L for your length, distance of wire. And you'll divide all that by your allowable voltage drop, which is in this case 4.155. For the distance, as you can see, it has changed. It has doubled. And that is because your wire run distance has to be doubled, because your electricity goes in one direction and comes back the same direction using your common wire. It goes into the appliance through your hot wire, and it comes back theoretically through your common wire, so it takes a round trip instead of just one way. So we double your distance for L. The division for finding CMA, which equals to 8,664.25 C-mils, and that is equivalent to the wire as shown in your wire chart, figure 3.3 again, as shown here on this sheet. The most economical way to mass produce an electronic circuit is using what type of method? Using automated machines, building printed circuit boards. Automobile is an example of the use of its blank as a part of its circuit. A chassis is part of the automobile's electrical circuit. Connection of peripheral devices to a PVC, that is a printed board circuit, is usually made by what? And that is edge connectors. What other types of transportation could use the frame or the chassis for part of the electrical circuit? There are probably a few. Some are the aircraft, trains, ships, and motorcycles. What type of switch is best for controlling lighting from 2 different locations? That would be 2 single-pole double-throw switches, 2 SPDTs. What does DPDT mean? That means double-pole, double-throw. What advantage does a circuit breaker have over a fuse? One of them is that it's resettable and reusable, and that it could be turned off and on easily. How are fuses sized? They're sized by its amperage rating, or the current level at which it will open or burn out. What type of lamp was invented first? Talking about lighting lamps or fixture. And it was the incandescent lamp by Thomas Edison. Several examples of electrical discharge lamps. First is a fluorescent lamp. Second is a compact fluorescent lamp. Third is the mercury vapor lamp, neon lamp, glow lamp, strobe lamp. What lamp provides the most economical lighting based on the amount of electricity used to create light? According to the text, which is based on a 2009 print, the highest lumens per watt or LPW fixtures are the high pressure sodium lamps at 100 to 140 lumens per watt. And I just inserted this note here. However, some sources as of 2018 project some types of white LED light fixtures at highest LPW lumens per watt. Explain how gas, like neon, becomes a conductor. When a very high voltage is applied to certain encapsulated gases, like neon, the gas will behave as a conductor. The high voltage continuously ionizes the atoms in the gas by the electrical pressure, making it glow. How is light intensity measured? It is measured in candelas and lumens. 1 candela is equivalent to the light of 1 candle in 1 foot radius as a sphere. 1 candela equals to 12.57 lumens. Write the color codes for the following resistor values. The first color, second color, the multiplier, and the tolerance. We're going to be using 4 color bands for each resistor. There may be 5, but commonly there are 4. Here are the resistor values as written out. They would not be appearing like that on most resistors. They would be color band coded. And here are the answers for the color codes for each one. First one, 2400 ohms at 10% tolerance. 2 equals to red, 4 equals to yellow, and times 100. That's the multiplier, is red. You add 2 zeros when you multiply by 100, 2400. The percentage of tolerance is silver. There are 3 percentages. One is silver, 10%. The next one up is gold, 5%. And the lowest tolerance is 20% for no band at all, no color shown. 680 ohms at 5% tolerance. You show it as blue for 6, gray for 8, black for 0. The multiplier is not 100 but it's 10. So the multiplier in this case would be brown, not black. So if you multiply by 10, it would be brown. So blue, gray, brown, and gold for the 5% tolerance. Second one is 91,000 ohms at 20% tolerance, which is white for number 9, 1 for brown, and orange for the multiplier over 1,000, and no band at all for 20%. So white, brown, orange, and no band. Next one is 27 ohms at 10% tolerance. So the first number is a 2 represented by red, 7 is represented by violet, and black to multiply by 1. So 27 times 1 is 27. Silver to represent tolerance. 3600 ohms is represented by red for the 3, blue for the 6, and then red for the 100 multiplier. Gold for 5% tolerance. The next one is 100 ohms. So it's brown for 1, black for 0. That's 10 times 10, which is brown, the multiplier. And silver is the last band that shows 10% tolerance. 5.1 ohms at 5% tolerance is 5. Green followed by K for the dot or the period. Brown for 1. Black for the 1 multiplier. And gold for 5%. 9.1 mega ohms, 10% tolerance is shown as white for 9, K for the period, brown for millions or mega multiplier, silver for 10%. Draw the symbols for the following: a fixed resistor, a tapped resistor, a potentiometer, and those will be shown here in this page. What is the standard unit for measuring a conductor cross-sectional area? The circular mil or C-mil. A mil equals to what amount of inches? How many inches? 0.001 inches. That is 1/1000. A round conductor that is 1/8 of an inch in diameter has a C-mil area of fill in the blank. For that, we take a few steps just to make it clear. A C-mil equals to the diameter of a mil squared. That is the equivalence between a C-mil and a diameter of a mil squared. Those two are equivalent. Next equivalency is 1/8 of an inch equals to 0.125 inch. The last equivalency is 1 mil equals to 0.001 inch. Those are all diameters. Remember that. 0.125 mil is the same as 0.001 inch in diameter times 0.125 inch in diameter. That is what 0.125 mil will be, or 1/8 of a mil. To make it equivalent, you multiply those two in the last step, 0.001 times 0.125, and you get 125 in diameter mils, which is equal to 0.125 mils. So continuing on, C mil equals the diameter of mils squared, just a reminder. So if C mil equals 125 mil squared, then C mil equals to 15,625 C mils. That's after you solve for the squared. You multiply 125 times 125. That is your answer. Which conductor has the larger cross-sectional area? The number 22 or number 10? Talking about the American wire gauge. And then it's of course the number 10. For this you can see chapter 9, table 8 of the NEC. A 20 amp lighting load is connected to a 120 volt source 300 feet away. How much voltage drop or loss is caused by using a number 12 aluminum wire? The wire resistance per 1,000 feet is 2.57 ohms. But we do not have 1,000 feet. We only have 300 feet. Again, we have to double the 300 to get the voltage, the real voltage drop, the true voltage drop. So doubling 300 is 600. So we still don't have 1,000 feet. We have 600 feet. So to find what the equivalent of what 1 kilofoot of resistance in ohms is, we have to find out the equivalent in kilofoot for 600 feet. For that, we divide 600 into 1,000 feet. 600 feet divided 1,000 feet equals 0.6 kilo feet. That is the equivalent to get your true resistance. So 0.6 kilo feet times 2.57 ohms will give you the resistance of 0.6 kilo feet instead of 1,000 kilo feet. So multiplying that, you get 1.542. So 1.542 ohms, the resistance for 0.6 kilo feet. And after that, you can write Ohm's law. Voltage equals current times resistance. Again, you should know this. You should recite this in your dreams. So you get voltage equals 20 amps. It's given above for your load amperage for the lighting. Multiply that by your resistance for 0.6 kilo feet, which is 1.542 ohms. Multiply those and you get 30.84 volts. And that is your voltage drop. And out of 120 volts, we do not want to drop more than 3.6 volts. So by dropping 30.84 volts, we're going way beyond the 3% maximum voltage drop. Something needs to give, something needs to be improved. And those things could be, again, one of four things. Your material has to change, your length, your distance of the wire needs to change, your wire gauge or wire diameter needs to change, or your voltage needs to change. A fifth thing could change, and that is your lighting load. That could decrease as well. Which is a non-profit company that tests electrical equipment safety features. That'd be the UL, that is Underwriters Laboratories. Which organization is responsible for the study of fire science, safety, and prevention? That'd be the NFPA, National Fire Protection Association, which is the set of standards that is used as a minimal safety guide for the installation of electrical equipment. That would be your NEC, National Electric Code, which is part of the NFPA. Which organization is a branch of the U.S. government and is responsible for workplace safety? OSHA, and that is Occupational Safety and Health Administration. You would most likely use a or an blank for assembling a circuit temporarily, a breadboard. To open two circuits simultaneously, you should use what type of switch? A double pole, double throw switch. The first electric lamp had a or an blank filament, fill in blank. It had a carbon filament, later replaced by tungsten and other metals. Name 4 different types of resistors. Carbon composition resistor is one. The molded composition resistor is another. Film resistor is a third. The wire wound resistor is a fourth type. And the adjustable resistor is fifth. What are the two major classifications of film resistors? Thick film and thin film resistors. What is the film resistor substrate made of? It is made of metals or carbon mixed with a precise proprietary formula. What does the numeric value 102 indicate on the surface mounted resistor or SMR? That would indicate the resistance value in ohms. The first 2 digits indicate the numeric value. The third digit indicates the number of zeros to add to the numeric value. So 102 means 1000 ohms. What color code would be a 1200 ohm 2 watt resistor? It would be brown for 1, red for the 2, or the first 2 digits, and then red for the multiplier, the 100 multiplier, and it would have probably a tolerance band, either gold, silver, or no band at all for 5, 10, or 20% tolerance. The wattage would be indicated in numeric value, such as 2 watt, 2W for 2 watt. What color code would be used on a 1.2 ohm resistor? It would be brown, K for the dot or the period, and yellow for the 2. There would also be a multiplier. In this case, it would be black for 1, so brown, K, yellow, and black. What color code would be used on a 1.2 mega ohm resistor? It would be brown for the 1, K for the dot, yellow for the 2, and blue for the mega or million multiplier. Record the resistance values of the following resistors as shown. There are 4 resistors here. First resistor on the upper left is brown, gray, orange, and gold. First color, brown, represents 1. Second color, gray, represents 8. The third color is orange, and it represents the multiplier, which is in this case 1000, which is 18,000 in total. That is ohms, and the gold band represents 5% tolerance. The second resistor, the top right, we have orange, red, and gold. So the first 2 colors represent 4 and 4. The third color, red, represents the multiplier of 100 ohms, and the fourth band represents 5% gold. That is the tolerance. The lower left has yellow on the left side, represents a 4. Brown represents 1, 41. Multiplier in this case is again 1000 for orange, 41,000 ohms. And the silver on the right side represents 10% tolerance. The fourth lower right resistor has only 3 bands, and it's brown, represents a 1, gray represents an 8, and orange represents the multiplier, which is 10,000. We have 18,000 ohms. Having no band on the fourth spot means 20% tolerance.